Hello everybody, this is Hari Krishna, Assistant Professor of Chemistry, Department of H&S, Annamacharya Institute of Technology and Sciences, Tirupati. Today we will discuss Unit 4, that is Cement and Concrete Chemistry. After completion of this unit, we come to know the preparation, properties and uses of cement and concrete. Coming to the subject, so these are the materials which is used for construction purposes. So these materials can be prepared from clay, rocks, sand and wood. In many countries there are many industries for the manufacturing of building materials. Coming to the cement, cement is nothing but it's a finely powdered mixture of calcium silicate and calcium aluminate, and it has a property of setting to a hard solid structure. That means it binds with building blocks, stones, bricks, etc. Coming to the classification of cement, there are mainly 5 types of cements. So first one is natural cement. It is prepared by mixing together of naturally occurring limestone along with clay. So it is not used. It possesses less strength. Second one is slag cement. It is prepared by mixing blast furnace slag with slaked lime. Next, Puzzolana cement. Puzzolana means high volcanic ash. So this is prepared by mixing high volcanic ash with lime. High alumina cement. This is prepared by mixing of bauxite with lime. And finally, Portland cement. This Portland cement is prepared by mixing of calcareous matter, that is lime containing matter, and argillaceous matter, that is clay containing matter, and along with 2 to 3% gypsum. So it was discovered by Joseph Aspidin in 1825. So this has quick setting and hardening property when made into paste with sand and water. Coming to the chemical constituents of Portland cement. So these are the constituents present in Portland cement. So that is tricalcium silicate, that is 45%, dicalcium silicate, that is 25%, tetracalcium aluminoferrite, that is 9%, calcium sulfate 5%, and etc. So coming to the manufacturing of Portland cement. So here Portland cement can be manufactured in 4 ways. So that is mixing of raw materials, burning, grinding, storage and packing. So coming to the mixing of raw materials, so what are the raw materials used for the manufacturing of Portland cement? So mainly calcareous material, that is limestone, chalk and marble, argillaceous materials, that is clay, slate, etc. Next, for burning of the cement, we use coal or fuel. Next, gypsum which is used as a retarding agent. So these are the raw materials which is used for the manufacturing of Portland cement. So coming to the first process, that is mixing of raw materials, which is done in 2 ways. One is dry process, another one is wet process. In dry process, we are having raw materials, calcareous material and argillaceous material. These two materials are crushed into fine powders in gyratory crushers and kept aside for the next process. And then in wet process, so first calcareous material is crushed into powder and argillaceous material along with water is made into a paste, and these two are mixed. That is called as a wet slurry. So this wet slurry is stored in silos which is kept aside for the next process, that is burning. So burning of raw materials. So here it is carried out in a rotary kiln, which is a steel cylinder and lined inside with refractory bricks. So here refractory material means the substance which can withstand high temperature without undergoing deformation in its shape. So those are called as refractory materials. So here the rotary kiln is lined in slightly inclined position towards the lower end. Now the raw mixture of dry process and wet slurry of the wet process are injected into the kiln from the upper end. So the kiln is heated with the help of powdered coal or oil or hot gases from the lower end of the kiln, so that long hot flame is produced. Now the following reactions takes place in the rotary kiln. So based on the temperature, so this rotary kiln has divided into three temperature zones. So first zone is drying zone. So it is the upper part of the rotary kiln where the temperature is only 400 degrees Celsius and the slurry gets dried here. That means most of the water is gets evaporated in the drying zone. Then coming to the next zone, calcination zone. Calcination means heating the substance in the absence of air. So here it is the central part of the kiln where the temperature is maintained at 1000 degrees Celsius. Limestone of dry mixture or slurry undergoes decomposition to form quicklime and carbon dioxide. Here calcium carbonate undergoes decomposition to give lime and carbon dioxide. And next zone is clinkering zone. This is the lower part which have temperature range in between 1500 to 1700 degrees Celsius. Here the lime and clay reacts to yield calcium aluminate and calcium silicates. So the aluminates and silicates of calcium fuse together to form a hard grey stones called as clinkers. Here in this clinkering zone, lime and silicates undergoes reaction and forms dicalcium silicates, tricalcium silicates, tricalcium aluminoferrites, tetracalcium aluminoferrites. So these looks like a hard grey stones which are called as clinkers. Now the clinkers are cooled and are collected in trolleys and it is passed to the next process, that is grinding of clinkers. Now these cooled clinkers are grind finally into powder in a ball mill. Here now gypsum is added 2 to 3% as a retarding agent. So coming to the final reaction, three molecules of CaOAl2O3 and with the gypsum it forms CaAl2O3 CaS447 7H2O, and finally it is passed into the storage and packing. The grind cement is stored in silos from which it is fed into automatic packing machine. Now it is passed into the packing machine and we get these cement packets, that is done in storage and packing. Next, coming to the phases of cement clinkers. Here when we are burning the cement, it forms different types of clinkers. That means it has the properties of setting and hardening in the presence of water. So they are known as Bogue compounds. So these compounds are referred as a halite, bilite, sielite and phthalate by Leach Atelier and Thornburn. So first coming to the halite, so it is the best cementing material and is well burnt cement. It is about 25 to 50% of cement. That means it contains 25 to 50% of cement. So it is easier to grind, increases the resistance to freezing and hydrates rapidly, generating high heat and develops an early hardness and strength. So it consists of 25 to 50% of cement and it possesses early hardness and strength to the cement. Next, dicalcium silicates or bilite. So it is about 25 to 40% of cement. It hydrates and hardens slowly and takes long time to add the strength. So it gives resistance to chemical attack. So here when we are rising the dicalcium silicates, that is bilite, which reduces the early strength and decreases the heat of hydration. So next one is sielite, that is tricalcium aluminate. It is about 5 to 11% of cement. It rapidly reacts with water and is responsible for flash set of finely grounded clinker. So the rapidity action is regulated by addition of 2 to 3% gypsum. So it is responsible for the initial setting, high heat of hydration. So rising the zeolite content, reducing the setting time, weak resistant to sulfate attack and lowers the strength. Next one is phyllite, that is tetracalcium aluminoferrite. So it is about 8 to 14% of cement. It is responsible for flash set but generates less heat. It has the purest cementing value. So rising the phyllite content reduces strength slightly. Now coming to the reactivity of clinker phases, when these assemblage which main mineral crystalline species are, so halite, it is roughly Ca3SiO5, bilite, it is roughly Ca2SiO4, and the main reactions of clinker phases are the proportion of clinker liquid increases and nodules form. Intermediate phases dissociate to form liquid and bilite. So bilite reacts with the free lime to form halite, and some volatile phases evaporates during these reactions of clinker phases. Now clinker liquid and nodular formation. So at about 1300 degrees Celsius, the portion of liquid starts to increase by 1450. Perhaps 20 to 30% of the mixture is liquid. Now the liquid forms from melting ferrite and aluminate phases and some bilite. The liquid content is more than the sum of the aluminate and ferrite phases in the cooled clinker because of the dissolved lime and silica. Next, coming to the parameters to characterize the clinker formation. Now the characters of clinker formation, that is lime saturation factor. So here lime saturation factor is the ratio of lime to that of silica, alumina and iron oxide. That is the given equation by LSF equals to CaO divided by 2.8 SiO2 plus 1.2 Al2O3 plus 0.65 Fe2O3. Here it controls the ratio of halite to bilite in the clinker. A clinker with higher lime saturation factor will have high proportion of halite to bilite, then will be clinker with low lime saturation factor. So the lime saturation factor values in modern clinkers are 92 to 98%. Values above 1 indicates that free lime is likely to be present in the clinker. When lime saturation factor equals to 1, all free lime should have combined with bilite to form halite. If the higher lime saturation factor is higher than 1, the surplus free lime has nothing which to combine and will remain as a free lime. Next, coming to silica ratio. So the silica ratio is defined as the ratio between SiO2 by Al2O3 plus Fe2O3. That means it is the ratio of silica to that alumina and iron oxide. A high silica ratio means that more calcium silicates are present in the clinker and less aluminates and ferrite. Silica ratio is typically between 2 and 3. Next, alumina ratio. It is the ratio of alumina to that of iron oxide. This determines the potential relative proportions of aluminate and ferrite phases in the clinker. And increasing in clinker alumina ratio means there will be proportionally more aluminate and less ferrite in the clinker. In ordinary Portland cement clinker, the alumina ratio is usually between 1 and 4. Next, coming to the very important topic, that is setting and hardening of cement. So when Portland cement is mixed with water, it forms a plastic mass called as cement paste, which sets to be a hard mass like structure. So this process of solidification consists of setting and hardening. Coming to the definition of setting means stiffening of the original plastic mass due to initial gel formation is called as setting. And coming to the hardening, development of strength due to crystallization is called as hardening. So the initial setting reactions is given by first two reactions where gels are formed. Due to gel formation, it arises the stiffness, it gives the stiffness to the cement, that is called as setting. So these are the four equations for setting and hardening. In these four equations, here they are producing gel and crystal. Due to gel formation, setting is obtained, and due to crystallization, development of strength takes place, so that is hardening. Coming to the tabular column, so cement plus water paste for after 1 day's hydration of the tricalcium aluminates and tetracalcium aluminoferrates takes place, and after 7 days gelation of dicalcium silicates and crystallization of calcium hydroxide takes place, and after 28 days gelation of dicalcium silicates and tricalcium silicates, crystallization of calcium hydroxide takes place. So these are the uh, time process for the cement. Now coming to the concrete formation, scheme of concrete formation. A concrete is a hard strong building material by mixing of cement with sand and gravel with sufficient water to cause the cement to set and bind the entire mass. That means we are mixing the Portland cement with sand and gravel to form the concrete. So concrete is one of the most frequently used building material. When aggregate is mixed with dry Portland cement and water, the mixture forms a fluid slurry that is airly poured and molded into shape. The cement reacts with water and the other ingredients to form a hard matrix that binds the materials together into durable stone-like material. Most concrete is poured with reinforcing materials to provide tensile strength, yield reinforced concrete. Now coming to the admixtures of concrete improvement. For improving the concrete strength, hardness, etc., we have to add some admixtures. So admixtures are classified according to their function. So there are 5 different classes of chemical admixtures. All other admixtures falls into a special category whose functions include corrosion inhibition, shrinkage reduction, alkali silica reactivity, workability enhancement, bonding, damp proofing, and coloring. So now first one, coming to the admixtures, that is retarders. So when we are adding this admixture, they slow down the initial setting of concrete, that is keep the concrete workable for longer time for placement. So these are generally used in large or difficult placement conditions when partially setting before the placement is complete. So admixtures like sugar, water soluble carbohydrates such as soluble starch, dextrine, etc. are the examples for retarders. Next, accelerators. So accelerator means speed up. So they speed up the initial setting of concrete. So that is rate of development of strength at early ages. Example for accelerators is calcium chloride and NaCl. Next, air entertaining agents. So they help to incorporate a controlled amount of air in the form of bubbles distributed throughout the body of concrete during mixing. Air entertainment will reduce damage during freeze the cycles, thereby increasing the concrete durability. So example for air entertaining agents are natural wood resins, various sulfonate compounds, animal and vegetable oils such as olive oil, tallow, stearic acid, and oleic acid. Coming to the grinding agents, so these are the admixtures used to grind the concrete into required shape or size, which is used for construction purpose. Example, mobile cone crusher, mobile concrete crusher, and finally super plasticizers. So they increase the workability of the green or fresh concrete to have higher flowability with increasing the water content, which results in faster rate of concrete placement. Easy of placement to relatively poorly accessible locations without vibration, good shutter finish for highly reinforced concrete members, and reduction in cement content. Superplastizers are high range water reducing admixtures. So advantages of water reduction is hardened state of concrete or increased strength, density, durability, volume stability, abrasion resistant, reduced permeability and cracking. So examples for superplasticizers is carboxylic acid and lignosulfonates. Next, dispersants. Surface active agents alter the physical chemical forces at the interface. They are adsorbed on the cement particles, giving them a negative charge, which leads to repulsion between the particles. So adsorption means it's a surface phenomena. Electrostatic forces are developed causing disintegration and the free water becomes available for workability. And corrosion inhibitors. They are used to slow down the corrosion of steel and steel bars in concrete. So mainly corrosion inhibitors are sodium nitrate, sodium benzoate. Next, water or damp proofing and permeability reducing admixtures. These improve the resistance of concrete to penetration of moisture. The admixtures prevent the water penetration of dry concrete or stop the passage of water through the unsaturated concrete. Example, soda and potash soaps. Bonding admixtures. These are used to create a bond between old and new concrete. Pigments. These are used to change the color of concrete for decoration purpose. Examples, cobalt, chromium and iron. Next, pumping aids. They improve the pumpability of concrete, thicken the paste and reduce dewatering or bleeding. That is the tendency for the water to separate out of the paste. Next, gas forming admixtures. So it when added to the mortar or concrete mixture reacts chemically with hydroxides present in the cement and form minute bubbles of hydrogen gas throughout the cement water matrix. So this action prevents bleeding and improves the intimacy of contact of the paste with adjacent concrete or aggregate particles as well as embedded steel reinforcing bars. Examples, aluminum powder. So these are the admixtures which are added to the concrete to improve its strength. So this is the unit cement and concrete industry. So with this we complete the unit, and here after completion of this unit we can know that how to prepare cement and where the cement is used and concrete preparation properties and admixtures of cement and concrete. So thank you very much.